So what we have here is the 2019 Higher Paper 1, and it's question 15 from that paper. This question focuses on trigonometry and trig identities that we're going to have to use within the course. We're going to have to use this one here to firstly solve an equation, and then secondly, hence, solve another equation, so hence being, use what we've just done before to get some sort of relationship between the two equations to solve them and get me the answer for this. Now, let's look at part A and focus on that to begin with. In this sort of question here, what you'll notice is that we've got a sine 2x and a cos x. Now, whenever you get a question like this that's got a sine 2x or a cos 2x in it, what you want to do is get rid of that using one of the trig identities that you've got for it. Now, luckily for us, we've got sine 2x, and we know that sine 2x only has one identity that we want to substitute in. And that identity is 2 sine x cos x. If we substitute this into here, we get rid of everything reliant upon the 2x being as part of the trigonometric function. We could put everything in terms of sine x and cos x and work to solve it from there. If it was cos 2x that we were going to get rid of, we could use one of the 3 trig identities that we've got that exist for the cos 2x. But at this stage, we don't have to worry too much about that. So sine 2x is this, so what I'm going to do is substitute that into the equation here at part A. What I'll end up getting is 2 sine x cos x plus 6 cos x equals 0. So now we're at a point where we can start to look to solve this equation. What you'll notice is that both terms have 2 cos x as a common factor. So let's take that out. So I'll end up with 2 cos x bracket sine x plus 3 equals 0. Now for this, I've got this times this, so one of them has to be 0. We're not told which one, so let's work them both through. So I could say fine, so 2 cos x equals 0, or sine x plus 3 equals 0. Now I look for my solutions for both. Well, 2 cos x is equal to 0, which means that cos x has to equal 0, and for cos x to be equal to 0, x has to equal 90 or 270. Now remember, the question's asking us to strictly limit it between 0 and 360. Obviously, I could then do 180-degree repetitions of this, but limiting it to a range, 90, 270 is what we want. Sine x plus 3 is equal to 0, so that tells me that sine x is equal to negative 3. However, sine x equal to negative 3 has no answer. Sine x can at no point equal negative 3. Remember, it's got a limit of 1 and negative 1. If we were to say 3 sine x equals negative 3, that's a different kettle of fish altogether. But sine x equals to negative 3 doesn't have a solution, so therefore at this point we have to write that there's no solutions. It's not enough for us to know in our heads that that's the case. We have to communicate our answer clearly and tell the examiners that actually we know there are no solutions to this. So I've got my answers coming from the cos x part here. The sine x bit here gives me no solutions as part of the equation. Quick point to note, here I've taken it the 2 as a common factor. If you weren't to do that, you'd end up with cos x equals 0, 2 sine x plus 6 equals 0. You'd still get the same set of answers. You'd be totally fine. The big key thing to take out as a common factor here is the cos x. Now, part B says, hence, solve this equation here for 0 less than or equal to 360, but what you'll notice is that these values have changed. Now, if you compare that with the first equation, what you'll notice is that each of these is twice the value that was in front of the x for both of these bits here. So what that means is by doubling those values there, I'm decreasing the period of the function, i.e. how long it takes to repeat itself. So I'm halving that. So what that means is if I were to just take, for example, cos x, if I were to draw just the cos x on its own, there would be our normal cos graph, so between 0 and 360, so a rough sketch of it. If I were to look at cos 2x, what that would mean is the graph would then repeat twice between 0 and 360, because my period would be reduced and become 180 degrees. So what that now means is that this curve here, however it's shaped, repeats twice between 0 and 360. So what that means is I'm going to get another set of solutions similar to this. So if I were to then look at my solutions, and let's imagine we're then going to change the limits between 2x being between 0 and 720, what that would mean is that this curve would then repeat itself over. So I would end up with 2x being equal to 90, 270, and then another repetition between 0 and 720. Now this repetition would then be essentially me adding on 360 to each of these values to repeat the curve again. So this 90 would be 90 plus 360, so that would be 450. And then 270 plus 360, that would then give me 630. So now what I've got is I've got my two sets of solutions if I were to imagine it repeating twice. So to get all the answers for this, I'm going to scale it back down by halving them. And what that then means is that x is equal to 45, 135, 225, and 315. That there would then be the set of solutions for this equation here between 0 and 360. Again, like I say, think about it as repeating the number of times it can go between 0 and 360 by doubling it in this one, changing the period and the length of the wave. This kind of question here is worth 5 marks total. Part A is worth 4. Part B is worth 1. So part A, for the 4 marks there, you get 1 for knowing the substitution, 2 for knowing to take the common factor out, and then 3 and 4 can be awarded in 2 different ways. 3 and 4, and the way I'm doing it, 3 would be for splitting it up and knowing you got the 2 there, and then 4 would be for knowing how to interpret the solutions. However, if I maybe misinterpreted at this line here, let's say I had 2 cos x equals 0 and sin x minus 3 equals 0. So I've misinterpreted this second bracket. So it would look like I lose this mark here, but then I would lose another one. But that's not the case because we can mark it vertically as well. So I could also get 3 for that and 4 for that. If I were to mess up this part here and work it through, even though I might get the right solutions for that one there, I would still lose this mark. But I could still gain this mark by interpreting the other part of the question correctly. So it can be either marked horizontally as I've done the working, or vertically. The bottom line is you can still get marks 3 and 4 for both parts of that there. And then for this second part, obviously it's 1 mark, getting your set of final answers. Very, very common question to come up in the exam, particularly paper 1, if it's given as this sort of setup as you like here.